Hi, and welcome to Big Data Analytics project presentation. Our project is stock signal generation using real-time news analysis. So to give a summary overview of our project, what we are doing in this project is that we are capturing all the news that has been pushed out in Twitter. Of course, we are not listening to all the news sources, but some. And also news related only to one stock, that is Apple stock. And we're trying to summarize that news, hourly news, into a score or a signal, which then can be used for any decision making purposes. So to give you an overview of our project, we'll be going over the methodologies, results, and solution architecture. And the methodology is actually quite simple. That is, we are listening to the Twitter stream, and we are ingesting the tweets. We are filtering the tweets based on the news sources that we have determined and the stocks, stock related keywords. And also then we are scoring based on a heuristic algorithm that we have developed, and the score is between -2 and +2. And for all the hourly tweets, we are normalizing the score into one data point, and we are plotting that hourly data point. So for ingestion, we are leveraging an open source API called TweetPy. So this API allows us to listen to the Twitter stream and filter at the stream level itself based on the source, and that is the Twitter handle from which the tweets are originating, and also from the we can apply the filter keywords at the stream level itself. Now the good thing about these APIs is that we can run multiple clients on different servers, and we can have really distributed Twitter stream consumption, so that we are not overwhelmed by the fire hose. In our case, since we are filtering based on a limited number of news sources and a limited number of keywords, we don't one client was enough. But in case we want to do it for a large portfolio of stocks, then you can have multiple TweetPy clients and listening to different sources and based on different keywords. Another good thing about this API is that it provides recovery logging and other stream processing features out of the box. So filtering, we are limiting ourselves to using these sources and these keywords. So we have an equity research analyst working in a major financial services firm in our team, and who is able to help us identify these sources, like which of these sources make sense, which of them have relevant data, relevant tweets for Apple stock, and what would be the relevant keywords based on that. So and these source and keyword level filtering is done at the streaming layer itself, and after that we are using some other filtering criteria, such as based on the language, location from where the tweet originated, and if the tweet had any special characters or not. But in effect, news source was the best filter that we got, and it filtered out most of the junk for us. So the for scoring, we created actually a training data. We filtered, we collated a set of tweets which we thought would be relevant, and then we manually, again the equity research analyst in our team, he manually assigned the ratings of these tweets from +2 to -2. And once we assigned these ratings, we created an algorithm and then tweaked it, refined it in order to make it become as close to the manual rating. For doing that, the algorithm uses word scores. For example, Blockbuster would have a higher score, and Crash or something like that would have a lower score. And like also pair of words, for example, big hit or big gain would both mean different things depending upon what is the next word with the word big. So the pair of words is also important. And we also allowed the weight of geography, number of followers, number of retweets, and even the source also count in the algorithm. So as I said, the scoring output is between +2 and -2, and every hour, if we normalize it every hour. So every hour, suppose we get 100 tweets, we add up the score of all the tweets and divide it by 100, and that's our data point that we plot. So let's dig a bit deeper into the tweets. So for example, if you see the rightmost topmost tweet, it says Apple reaches $700 billion evaluation. So it's a positive tweet because we know that the valuation increased, but the algorithm has no way to determine this context sensitive information, so it is giving a score of 0. But in other cases, if you look at the rightmost to bottommost, like second from right in the bottom tweet, that is Apple stock takes a big hit, tracking US markets with it. It has all the indicators like big hit, dragging, these things, so that allows the algorithm to score it perfectly. As you can see, the blue line is the scoring, the hourly score data points, and the green line is actually the stock price. And this is done for 5-day, and we see that it doesn't really follow the stock prices as much, but it captures the overall trend, and which is what our intention is. We never think that we can model the stock prices really, because if someone can do that, that would be like solving a big problem. But at least in terms of giving an hourly summation of news, I think this works pretty well. So this is the entire solution architecture for the project. Obviously not all of the things have been implemented, but this is something, if you want to develop it into an enterprise solution, how we'll be doing that. So as I already mentioned, we have a Twitter source and we have 2 clients listening to it, and we can have multiple nodes listening to that based on various stock tickers, or based on other components that you want to really do an analysis on. And then these tweets will be pushed onto a message queue, which could be a Kafka cluster, and then these messages are picked up by the scoring engines that could also be distributed across multiple systems, and these scoring engines would be listening to those messages, and based on those tweets they will score, and they will invoke the scoring algorithm pertaining to that particular signal for which needs to be generated. And after the score is generated, they'll push the data into the database. Now we have 2 databases here. One is a MongoDB, which will be storing the JSON, actual JSON tweet object, and one would be the MySQL database, which will have the tweet ID and the score and timestamp and other things. So for generating the graph, we'll be leveraging both, in the sense the initial graph would be generated using the MySQL databases, but if somebody wants to zoom in at a particular data point and wants to see what were the tweets that really contributed to that particular data point, he can do so, and for that we'll be leveraging MongoDB. So there are a lot of things that we can do as part of feature work. Some of these things are, as I mentioned, context sensitive information. We don't have any mechanism to capture that. And also for semantic scoring, for example, if it is a speculation or a question that is being asked rather than a fact that has been stated, then we don't really handle that well right now. And we can always increase the news sources for higher accuracy, and we can also leverage NLP to capture missing news. For example, if a word is not spelled correctly, and if some of the words in a part of speech are missing, or things like that, we can use NLP to actually capture those tweets in a more realistic fashion. And macroeconomic indicators. For example, if a job report comes out and it is a big deviation from the previous job report, that would have some effect on the signal, but we are really not capturing that right now. And then overall technical infrastructure and latency and other things that could be worked upon. So that is our project. Thank you very much, and hope this was helpful to you. Thank you.